example you're going to use. So hot. Can you do the lights again? That's good. That's good. So you guys, if you're worried about, we are having a quiz on Monday. I don't want to not do that. I'll give it back to you first thing Tuesday during that initial 30, 40-minute period before we actually do the test. So that's one thing y'all should be doing is making corrections to that. We'll talk about that. You guys understand?
So the corrections are due the same day as the test?
No. I'll give you some leeway on that. Right. I'm the guy that makes the deadlines. I can push that back. All right, so if you guys read through the premise up here. This is back when, I don't know if you guys remember Joe the Plumber. Was it Joe the Plumber back in 2008 or whatever? Sarah Palin? No? Okay.
It didn't turn out not to be like...
So I had like a whole series of stats problems. Phil the researcher was one of them. Tim the tool man. Alright. Everybody's reading through this premise. We're doing the side that's got all the red writing and stuff. Okay. Do you understand the idea? By the way, I don't know if any of you know this. This is actually a true thing. They do live longer in captivity. That doesn't mean that captivity is better for every animal, but this is one that they better.
Right? I mean, it's just like my dogs. My dogs are not going to survive.
It sounds so great. I don't want somebody putting me in some cage.
I'm just saying that we keep that
Alright, guys. Good. So, somebody help me out. What is the claim that's being made? I was really nice in this problem, obviously, because I bolded the important parts. I'm not always going to do that. Say again? Beautiful. So the claim in English is, he thinks that the Minnesota lives longer in captivity than in the wild. Normally they live for 7.25 years. So the claim relates to that. I will never see the sample number showing up in my claim. Because you're going to make a claim before you even go take the sample, right? So obviously this is a problem. I got to give you the whole thing. But I'm going to make a claim before I even get the sample number. So 8.65, I don't want to see it up there. That's later. So our claim is that the average length of life for the Minnesota coyote is greater than 7.25 if they're in captivity. I like it. So now we got to talk about, this is going to relate to those. Oh, I'm sorry. You need that?
Yeah.
Okay. So remember, which one of these can I not prove? Good. The one I can't prove is going to be put in place where it says HO. That's the Null Hypothesis. I will affectionately call it the hoe. Don't like that? You're going to get over it quick. If it has, so here's a quicker way to say that. If it's got an equal sign in it, you're going to put it where it says HO. The Null Hypothesis. Or the hoe. So is our claim. So where am I going to put my claim? Which one of these statements will be my claim then? Is it going to be the hoe or the high? The high. Why? Because it doesn't have an equal sign. So the high is what's going to always set up where my benchmark is. Because that's the one I can actually prove. So the hoe is going to be the opposite. These are always opposites of each other. So what's the hoe going to be? So this sheet is really, really stupid good to have sitting next to you as you're doing this homework, because it explains all the steps and it also tells you what steps you got to do. So here, remember the null sign must have the equal sign, right? The null has the equal sign. What's your gut tell you about if it's going to be a one or a two-tailed test? Why is it only going to be a one-tailed test? Because I just need a sample that is above that. So that's the whole reason why the t-score chart has 1, 2 tail at the top. So you look at the right place. So this is definitely a one-tailed test. Which side will that tail be on? Yeah, up here. Because I want to find a sample that's so far up here that this can't be the middle. So if I find a sample that's just so far up that way, it's more likely the middle is in a different place than it is that I just happened to get that. Right?
But now if it was I just want to clarify, so if it was a sample and not the population mean, it would be 2.
No, definitely not. No, it's only going to be 2 tail if my claim is we think it's changed. Like if we think that the gas price changed, then this would have been not equal to. And how can you be not equal to something? You'd either be more or that would be a 2-tail test. It's the only time you're going to have a 2-tail test is if we're saying it's different.
Okay. Got it.
Okay, cool. Shoot, I forgot what I was going to say.
Sorry, I'm sorry.
That's all right. It'll come back to you. We'll see. Okay. What about part B? This is good. This is the part that we should definitely know. Yeah, 2 things we got to check. And I sort of spell it out for you. How do we know it's normally distributed? Yeah. So step 1, n equals, where to go? 41 greater than 30. Check. Normal enough. And then secondly, which standard deviation do we know? I was unbelievably kind. Yes. We know the population standard deviation, don't we? In fact, I was doubly kind because I didn't even list the sample standard deviation. I could have. But if you know the population one, hell yeah, you're going to use that shit. So what am I allowed to use then? It's normal. We know sigma. So then we can use z-scores. Of course, that's related to what we just learned earlier today. But does that step make sense? So if it's not normally distributed, you don't do that problem. But if it's on a test, you probably made a mistake. You should do it anyway. I'm never going to... Can you understand how evil that... How many more steps are there? 3 more steps? And they're probably kind of big? So if I made a problem, then I'm like, let's see who notices. They don't... Oh, no. God. You would have every right just to slap me full on. Right? So I'm not going to do that. So if you think it's not normal, you're probably wrong. Do the problem. Right? Okay. Alright, so now let me make sure this makes sense. We call this the rejection region. Because if I get a sample that is in here, that is so far away, that means I can reject the hoe. That means that it's not, it doesn't look like it's equal to this or around this area. It looks like it's more than that. That's evidence that it's more. It's way the freaking hell up here. So I call this the rejection region. I think the book calls it the critical region. Right? So if you see the word critical or critical value, that's a z-score for the critical region, blah, blah, blah. So, we know it's how many tail tests? 1 tail test. I know that alpha is 0.01. And we have z-scores we can use, right? 1 tail. Alpha is 0.01. So of course I'm going to look at my t-score chart. Does everybody think I'm insane? Good? Even though I am, it's not for this reason. 1 tail, 0.01. Go all the way down so I get my t-score, my z-score, 2.326. You guys see that? 1 tail. We're finally using this on purpose. 1 tail, 0.01, all the way down, 2.326. That is now...
Why do you go all the way down?
Because if I stop, what do I get? A t-score.
Right.
And what do we want?
We want the z-score.
Z-score.
So why
So
don't you use the z-chart?
I could. I'll get the same damn thing. And actually, I'll get a less specific number. You'll get 2.33. So let's try it again. You ready?
Can you just show me what
Sure,
the
sure.
z-score
That's what I'm going to do. Can I borrow somebody's? I think I've given all mine away. So 98, sorry. So it's a one tail, 0.01, so here. You don't want to do this the old-fashioned way. There's 0.01 there, right? So how much is down here? 0.99. So let's look at 0.99. .33, which is 2.326 rounded. I like it. See, so it matches. I really want you to have faith in that. I know it's a t-score chart, but t-scores are just z-scores that have been beefed up a little bit to cover us for not knowing something. The bigger my sample gets, the less I don't know. So when my sample gets large, what's large? I don't know. When it gets large enough, it becomes a z-score. So I can just use that. Now, if you don't like that at all, you just saw I got basically the same number. You can do it the old-fashioned way. No problem. So again, it's up here, right? 2.326. If it was down here, if my tail was down here, what would I put on it? Negative 2 point. We're the humans. We got to know when it's positive or negative. That's why there are no negatives on the t-score chart, because it's like, I ain't going to tell you negative. You just got to know it's negative. They don't want to make a beefed up. No, screw that. All right, may. So here's what this means. I really want this to make sense. If my sample ends up with a z-score more than that, I can say the HO looks wrong. I can reject the null hypothesis, reject the hope, support the high. Because if I get in there, is that evidence that the mean is not really here? Yeah. Because it's so unlikely that if the mean really is here, that I'm going to get a sample way the hell up here. When would I get a sample way the hell up here if the average was actually up higher? So that would be evidence that the H1 is true. I would support the H1, the high. Reject the hope. Where are you? So how do I say this works? By the way, what this is a z-score, right? So notice I use z star just to differentiate it. The one I calculate for my sample, I call it z star just to differentiate it. So if my sample z-score is greater than 2.326, we reject the hope, support the high. Because if I get a sample that's way up here, then that looks like this is wrong. It's not less than or equal to. It actually looks like this is right. Let me stop there for a second.
I see where, yeah, thank you.
If z star is greater than 2.326, so you can even shade it in. There's my little rejection region right there. If I get into that rejection region, if it's greater than this, we reject the hope, support the high. Sounds like proposition. We supported that. Okay. So now part D is going to be the one that's the most familiar step, because now we're just going to calculate the z-score. See how I say summarize the sample information. What do we know from the sample? How big was it? What was the mean they found? Careful. 8.65. And then I know sigma, right? 3.27. So right here, see this little note? You've got to change that because we're talking about sample means now, right? So don't I have to make the new standard deviation? That's old news. So what's the new standard deviation going to be? It's going to be the old one divided by the square root of what? 41. 0.511? Let me stop there for a second. So this problem's got a little bit more to it. So I like to summarize what I know that I need for my z-score formula. There's everything I need to know. And now I do the z-score. So the z-score is going to be our data, 8.65, minus the mean, what we're assuming to be mu, which is this dude. It's always the number from the claim. We're assuming this to be the mean, 7.25, divided by the new standard deviation. Oh, should I set it? Yeah. Oh. So that should feel familiar. I mean, that's the kind of thing we've been doing a lot of recently. So now I know, relative to the data, that's how far my sample got. That's, on its own, that's pretty far away, right? That's almost 3 steps away. It's almost 3 standard deviations away. That's far. Is it far enough relative to what our benchmark was?
Yes.
Yes. It's way up here, the little star on there, that correlates to Z star. Ooh. There's humor in it. And you're all like, that's what we do every day. So, by itself, that's enough to figure out if we succeeded the test or failed. Did we fail? We got in there. So that means we can do what? We got in there. We can reject the hoe, support the I. So you can write that. This means that we reject the hoe, support the I. I'm going to write the conclusion and then come back into the p-value next because it's just going to get in our way right now. Bless you. We stopped there for a second. If we wouldn't have gotten far enough, if the z-score we got was like 1.2, then we would fail to reject the hoe, fail to support the high. So if you make it in, you don't fail. If you don't make it in there, you fail. Yes?
The 2.3
Yes.
on part C,
Yes.
we're trying to get in above that
Yes.
because we're trying to prove that we need it.
Yes.
But how would we get through that is we're only going
So guys, now, how many problems have we done? Not even a full one yet. Okay. So that's number one. But this is a good question. This is the key question, actually. If this is what it looks like, I would expect a sample to be in there. That would be reasonable. That kind of relates to our 2.326. We're only interested in that side. That's why we only looked at that one tail. Is that cool? But just in general, I would expect my sample to show up in here somewhere, right? There is a probability that it would show up there.